Today we are going to solve two exercises, and after that in the next video we will move on to the next section, which is on related rates of change. We have spent enough time on implicit differentiation, but anyway, let's see this next one, number 46. Here we have to find the slope of this given curve, whatever it is, at these 2 points 1, 0 and 1, -1. I urge you to actually see how the graph looks. You can go on Desmos graphing calculator and see for yourself. So of course we have to do implicit differentiation. We have to differentiate both sides of this equation implicitly with respect to x, assuming that y is a differentiable function of x. So accordingly we start the solution. Differentiating both sides of the given equation implicitly with respect to x, we get this. So let's see what that gives us. So say you differentiate the left hand side. The left hand side, as you can see, is a composite of two functions, the outer square function and the inner function, which is x squared plus y squared. So first you differentiate the outer function, keeping the inner function intact. What does that actually mean? It means that you are differentiating the square with respect to this x squared plus y squared, treating it as a variable. Okay, in place of ordinary x, you imagine this x squared plus y squared. Had this been x squared, differentiating it, you would have got 2x. So just like that, now you are going to get 2 times this. And then you multiply that with the derivative of x squared plus y squared. And that is your chain rule actually, which is this. Now how does this come? Here also, first of all, of course, you have to apply the sum rule for derivative. So derivative of x squared is your ordinary 2x. And what is the derivative of y squared? Here you have to again apply the chain rule. First you differentiate y squared with respect to y. That gives you 2y, and then multiply that with the derivative of the inner function y with respect to x, which is just your ordinary dy dx. Similarly, you differentiate the right hand side. So you are going to get 2 times x minus y times the derivative of x minus y with respect to x, which is 1 minus dy dx. And then I did not show the intermediate steps. That is just algebra. No. From this equation, you solve for dy dx. This is what you will get. So I urge you to actually supply the missing steps and see what I wrote here really is what we should get. So it becomes x minus y minus 2x y squared minus 2x cubed divided by 2x squared y plus 2y cubed plus x minus y. So this is the slope of this curve, whatever it is, at some general point x comma y. Now we have to find the slope at these 2 points. And those slopes are these. You can substitute the values of the coordinates x equal to 1 and y equal to 0 here in this expression. You will see that you are getting minus 1. And at the point 1 comma minus 1, the slope is 1. And then we have number 56. Here we have to find the tangent and normal, that means they are equations to this curve, x squared times cos squared y minus sin y equal to 0 at this point 0 comma pi, which is a point on this curve. To calculate the tangent, we have to of course know the slope of this curve at this point. And to know the slope, we as usual differentiate both sides of this equation implicitly with respect to x, assuming that y is a differentiable function of x. So that's what we do, and the right hand side of course will be 0 even after differentiating. What about the left hand side? First of all, you have to apply the difference rule. That means the derivative of the left hand side will be the derivative of this minus the derivative of this. This is the easier one, so let's see that first. Even though it's the easier one between these two, still it's a composite function. It's the composition of sine and y, y itself is a function of x. So to differentiate this, you have to apply the chain rule. Differentiating the outer sine function, you get cos with respect to y, keeping the inner function intact, and then you multiply that with the derivative of the inner function with respect to x, which is your ordinary dy dx. What will you do here? Here you have to apply first the product rule. So if you keep cos squared y intact and differentiate x squared, you get 2x cos squared y. And then you keep x squared intact and differentiate cos squared y with respect to x. And there you have to apply chain rule, and this time, unlike this one, there are three functions. The outer squared function, then inside that you have the cosine function, and inside that you have the function y, which itself is a function of x. So you have to apply chain rule successively. First you differentiate the outer square function with respect to cos y. So that gives you 2 cos y. Okay, see carefully, 2 cos y. Already we have x squared. So x squared is there, we have now got 2 cos y, and then you differentiate, then you go inside. You differentiate cos y with respect to y. That gives you minus sin y. And then once more, you differentiate y with respect to x, and that gives you this dy dx. And then of course you solve for dy dx, and this is what you get. So here also you supply the intermediate steps, which is just algebra. 2x cos y divided by 2x squared sin y plus 1. And now we use this expression for the general slope to calculate the slope at 0, pi. The slope of the graph at a point will be the same as the slope of the tangent by definition at that point. So that's why we write, so the slope of the tangent at 0, pi is this. That means you just substitute x equal to 0 and y equal to pi. The denominator becomes what? 1, and the numerator becomes 0 due to this x. So that means the slope is 0. So whatever the graph is, for this graph also you go to Desmos graphing facility, you type in the equation and you see how the graph looks. And also you type in this point and locate the point on the graph. You will see that there the slope is 0. That means the tangent should be horizontal. Now what is the equation of the horizontal line passing through this point? Y equal to pi. So that is the tangent. It will be like this. And that is why the normal will be vertical. The normal by definition is perpendicular to the tangent and also passes through that point. Because the tangent is horizontal, the normal needs to be vertical. And what's the equation of the vertical line passing through this point? X equal to 0. That means the y-axis. That is the normal.